Hey, Apple. Hey, Apple. Hey, Apple. Hey, Apple. Apple. Hey. Hey, Apple.
What is it?
Aren't you glad I didn't say Apple again?
Yeah, that joke was funny the first 400 times you said it.
Hey, Apple.
What?
That, my friends, would be a great case for isolation. In a previous nugget on the concepts of private VLANs, we discussed how we could implement isolation and separation between devices, between ports on the same layer 3 IP subnet. In this nugget, you and I are going to walk through the steps of the implementation and verification of private VLANs. So let's go ahead and configure private VLANs, and I'll walk you through the commands as we go through it together. I want to start off by just defaulting several interfaces on my switch. Interfaces gig 0/11 through 15, so they know there's nothing there beforehand. If we're running VTP version 1 or 2, we need to set the mode to transparent. If you're using VTP version 3, that does support private VLANs. And in that case, we can set up a client or a server if we're using version 3. But for version 1 or 2, we need to be in VTP transparent mode. So we'll set that with the command VTP mode transparent. Next, we're going to create VLANs. Now we're going to create VLANs 500, 400, and 300. And in each one of them, we're going to simply use the command private-VLAN space community to indicate to the switch that these 3 VLANs that we're creating are going to be communities, VLAN communities inside of private VLANs. Now, although we can have multiple community VLANs, we really only need to have one isolated VLAN. So let's create that as well. We'll call it VLAN 200, and we'll use the keyword in VLAN configuration mode of private-VLAN isolated. And poof, now we have 3 community VLANs and 1 isolated VLAN. Now, of course, we also need our primary VLAN, which we decided was going to be VLAN 100. So we'll create VLAN 100 and simply use the command private-VLAN primary inside VLAN configuration mode. So let's check our work here. We have 300, 400, and 500 that we all specified as being community VLANs or sub-VLANs in our private VLAN scheme. We have our single isolated VLAN, which is VLAN 200. And then we have the primary VLAN 100. And we use the command private-VLAN for all of these, simply using the word community, the word isolated, or the word primary to indicate what type of VLAN that was going to be in our design. In our next step, we're going to tell the switch, hey, dear Mr. Switch, this primary VLAN of 100 is going to be associated with all these sub-VLANs that are participating as either secondary isolated or secondary community VLANs. And to do that, we're going to use the command private-VLAN association and then the list of all the secondary VLANs that we just created. So here's the 200, which is our isolated, right there. And 300, 400, and 500 are 3 different community VLANs that we also just created. So now the switch knows exactly which secondary VLANs are associated with the primary VLAN. Next, we're going to go into interface configuration mode for the interface that we want to be the promiscuous port, like the dock on the island that all other VLANs can access. And in interface configuration mode, we're going to specify switch port mode, private-VLAN, and the keyword promiscuous. So in interface configuration mode, now the switch knows that this port is a promiscuous port. Now, in addition, on this port, we have to specify what the primary VLAN that is going to be a promiscuous port for, and we're also going to specify the secondary VLANs, the isolated VLAN, and the other community VLANs that we created that are allowed to communicate with this port. And we're going to do that with the command switch port private-VLAN mapping the number of our primary VLAN, which is 100, and then our list of these secondary VLANs, which is 200, 300, 400, and 500. So again, let's do a quick check. We created our community VLANs, we created our isolated VLAN, we created our primary VLAN. We told the primary VLAN what the associated secondary VLANs are going to be. And now here on this interface of gig 0/11, we're specifying that it is a promiscuous port and the primary VLAN this port is a promiscuous port 4 is VLAN 100. And the secondary VLANs that are allowed to communicate with this port are 200, 300, 400, and 500. So it's very likely on this port gig 0/11, we are going to go ahead and place a router. And that way, any device connected in VLANs 200, 300, 400, or 500 can have access to their router, to their default gateway, to go ahead and get off of the local network. Now, just for grins, let's go ahead and add a couple of ports and place them in the isolated VLAN. So we'll go into interface configuration mode. We're using interface range for gig 0/12 through 13, those 2 ports. And we'll use the command switch port mode private-VLAN host. Now, the tricky part for the switch is it knows, because of this command we used, that they are going to be host ports in this private VLAN configuration. However, it doesn't know, the switch doesn't know yet, which private VLAN is participating in. So to fix that, we're going to use the command in interface configuration mode of switch port private-VLAN host-association, and then the VLAN number of the primary VLAN followed by the secondary VLAN that we want this port to be a part of. So in effect, this port is now a member of VLAN 200. That's our secondary VLAN, which is also an isolated VLAN. And these ports will also have access to the promiscuous ports that are in VLAN 100, which is the primary VLAN. To add a port to our community VLANs, now we have 3 of them to choose from, VLAN 300, 400, and 500. All we'd have to do is go into interface configuration mode for the port that we want to add to one of those VLANs and say switch port mode private-VLAN host, just like we did previously for the isolated VLAN, but this time, as we use the command switch port private-VLAN host-association, we'll list our primary VLAN followed by the community secondary VLAN. So the big difference here between ports 12 and 13 and port 14 is that we've linked port 14 to the secondary VLAN of 300, which is a community VLAN. So the good news is for this port, any other ports that are also part of VLAN 300, they'll be able to communicate with each other because they are in the same sub-VLAN or same subdomain or same community as each other. And just for grins, let's go ahead and throw port gig 0/15 into the other, or one of the other community VLANs that we created, and that's VLAN 400. So we use the command switch port mode private-VLAN host, and then switch port private-VLAN host-association, the number of the primary VLAN, and then the secondary VLAN that we want this port to be associated with. In this case, it's VLAN 400, so we'd use this number as our secondary VLAN, which is 400. So again, other devices that are connected to other ports, which are also part of VLAN 400, would be able to communicate with each other, as well as any promiscuous ports on the primary VLAN. Also, it'd be very helpful if these interfaces, these ports, were in an up state. So we'll go to interface range for them and do a no shutdown just to make sure that they are up. A really important aspect for you and I in these videos is that as we watch something, we'd also want to make sure we practice it as well and verify that it's working. So a simple command that we can use with private VLANs is show VLAN space private-VLAN, and that will show us the details for our private VLAN configuration. So here it's showing us the primary VLAN, which is 100. We have our secondary VLANs, the isolated, which is 200, and 300 through 500, which are community VLANs. It's giving us the types right here as well. And currently it only shows port gig 0/13 as participating in our private VLAN scenario. Well, that's because I don't have any devices connected to those other ports. So I'm going to take off the headset just for a moment and walk in the other room, plug in some devices so that we have link on those other ports. And then those ports which are associated with our private VLANs, they should start to show up here. Okay, so I am back. Let's use the up arrow key. Now that I have devices plugged into those ports, we'll do a show VLAN private-VLAN again. And what this command is showing us is that we have our primary VLAN, our secondary VLAN, and it's showing us the ports involved in them. So for example, gig 0/11 is in our primary VLAN. It is our promiscuous port. Gig 12 and 13 are members of the isolated VLAN, which is VLAN 200. Port 14 is part of the community VLAN, which is VLAN 300, and port 15 is participating in a different community, which is VLAN 400. And the reason it doesn't show any additional ports here associated with VLAN 500 is because we didn't configure any additional ports to be part of VLAN 500 in our private VLAN. We can also do a show interface for example, gig 0/11, which is our promiscuous port with the keyword switch port afterwards. So the actual command is right here. And that also will give us some insight regarding the role that that port is playing. So it is a promiscuous port. Administrative refers to how it's configured. Operational is referring to how it's doing. Those are identical. That's a good thing here. So the primary VLAN is VLAN 100, and the secondary VLANs are 200, 300, 400, and 500. And VLAN 200 was our isolated VLAN, so any ports in VLAN 200 wouldn't be able to see any other ports anywhere except for the promiscuous port. On the other end, VLANs 300, 400, and 500, any ports in any one of those specific VLANs respectively, would be able to see other devices in that same secondary VLAN, that community VLAN that they were a part of. So if we had several devices, and they were all connected to these secondary VLANs, these subdomains, if you will, inside of our private VLAN configuration, all of them logically would be on the same IP subnet. One other thing that you and I got to chat about before we leave this nugget is some security considerations regarding the use of private VLANs. Because all these devices are on the same subnet, let's say they're in the 10.1.1.0 subnet, just as an example, and maybe the default gateway that's connected to this port, this is our promiscuous port, maybe that router has the IP address of .1. Maybe that's router 1. And here's my question. If a device here had the IP address of .25, and over here in community C, we had a device connected to this port, and it had an IP address of .35, even though these two ports can't communicate directly with each other, because this port's an isolated port and this port is in a different community, what would happen if the attacker or the device on this port sent a packet to 10.1.1.35, but forwarded it to the layer 2 address of the default gateway? Well, if the default gateway has a route and it's directly connected to this network, the default gateway could then route it back to that port. And then you'd have communications between this port and this port. Indirectly, because they're going through R1, but they still have the ability to communicate. So to solve that, if we're using private VLANs, we could also implement an access control list on R1 inbound on this interface. And that access control list might say something like, please deny anything from 10.1.1 if it's also going to 10.1.1. And that way R1 wouldn't be doing any hairpin turns to route traffic from the 10.1.1 network back to other devices on that same logical IP network. So that would be an important security consideration as well as we consider the use of private VLANs in our infrastructure. And my friend, for our assessment check, take a few moments, read these 3 questions. If you need more time, just hit pause during the music, and we'll be back together to review them together. Good luck. And here we go. Question number 1, when can we use a VTP server or run VTP in server mode with private VLANs? And the answer is if we're using VTP version 3. If we're using version 1 or 2, we have to set our VTP mode to transparent. Question number 2, how can private VLAN security be bypassed? And the security of a private VLAN can be bypassed if a device, for example, on an isolated port or in community B, for example, sends a packet to the layer 2 address of its default gateway. In our example, we used R1, but at layer 3, it's going to be routed back to a device on a different community VLAN. And that's referred to as a hairpin turn or hairpin routing on this interface of R1. And the third question is, how can that be prevented? And the answer is we can put an access control list, ingress or inbound, on this interface in R1 that says, please deny traffic if it's coming from this specific IP subnet and going to that same IP subnet. That way, when the device connected to this port sends a packet to R1, if it's destined for the same IP subnet, R1, based on the access control list, will deny that packet and prevent the security breach. How did you do? If you got 3 out of 3, good job, my friend. Way to go. So there's lots of great reasons why we might want to implement private VLANs, including isolating certain devices on the same subnet from being able to communicate with other devices. And in this nugget, you and I have walked through step by step the process of how to implement and verify private VLANs. Hey, thanks for joining me in this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.